Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss on polymer technology. So one of the polymer called elastomers, and what are the elastomers and what are the examples of elastomers we are going to see in detail today. So the main focus is on Thiokol rubber and Buna-S rubber. So the elastomers preparation, properties and application part we are going to see of Buna-S and Thiokol rubbers. What is rubber? The rubber which is obtained generally from natural sources, especially from plant, are called the natural rubber. The rubber which is prepared artificially means man-made, which is called a synthetic rubber. Synthetic rubber holds a wide range of applications in daily life as well as in industries. So generally the elastomers are nothing but the polymers which having the elasticity property are called the elastomers. Under this category, they are elastomers which is having elasticity property are natural, synthetic and vulcanized rubber. It divided into three categories. So if it is a natural, which is obtained from natural source, and if it is a synthetic, it may be a man-made or prepared synthetically or artificially, and the vulcanized rubber. So the rubber obtained from natural process undergoes some process of chemical reaction, that is called the vulcanized rubber. So this is the natural rubber which is obtained from the rubber tree and Havelia brasiliensis. So this is a milk of latex which flows from the tree. A small incision is made on the tree which allows the latex or milk-like colloid present inside the tree, which flows on the incision and is collected in the vessels. This is called the natural rubber. So after collected, it undergoes a series of reactions, or it undergoes a series of preparation methods to convert into the rubber sheets. So the preservative, generally ammonia, was added to avoid the traces of other cations like calcium and magnesium. So they were preserved and strained, and it goes a series of reaction to convert into rubber. So the synthetic rubber, today our topic, we are focusing on this synthetic rubber. So here the synthetic rubber is artificial or man-made by the reaction of some monomer units like some chemical compound, and this is vulcanized rubber. The rubber obtained from the natural process undergo a reaction, means it was combined with the sulfur molecules, then it forms a cross-link between the rubber monomer units, then it gives the hard rubber called vulcanized rubber. So this natural rubber is obtained from the tree. A small incision, this is the small incision was made, it should be the lateral from left to right. So it should not damage the vessels of the tree trunk. Then the incision was made, and this latex, this is called white liquid, is called the latex rubber. Once collected, it undergoes process. So this is the solid form of, if it was allowed to dry, then it becomes a solid form which is like foam. So this is the solid form of rubber. So the vulcanization, these are here in the natural rubber, the isoprene units are the monomers. One isoprene unit and another isoprene unit are like multiple isoprene units results in the formation of polyisoprene units. So when this type of units are combined or reacted with the sulfur compounds, it gives the cross links between the isoprene units. We can observe the sulfur was formed between these two polymer chains. This is the cross link. This cross linked sulfur containing polyisoprene units are called vulcanized rubber. This process is called vulcanization. Now, under this natural, synthetic and vulcanized rubber, we are going to see on the synthetic rubbers. So, which are man-made or artificially made by the man. We are going to see the synthetic rubber today. These synthetic rubber are just like the natural rubbers. They have many uses in automotive industry for the manufacturing of tires, doors and windows and window profiles such as O-rings and gasket hoses and belts, matting and flooring. They play a vital role. These synthetic rubbers especially play a vital role. They have different physical and chemical properties which can improve the reliability of a given product according to their application. They have superior because compared to the natural rubbers in two major aspects, because they are thermally stable and resistant to oils and some related compounds. So they are chemically inert. So this gives an advantage of using this synthetic rubbers over the natural rubbers. They are more resistant to oxidizing agents such as ozone and oxygen, which can reduce the life of the products like tires. So when this natural rubber was used in tires, they should be, if we are using for a special or specially applicable to the one manufacturing unit, it should be the chemically inert and it should not react with the oxidizing or some chemical agents. So compared to this natural, these synthetic fibers are generally resistant to oils and some compounds, oil related compounds, and they are highly resistant to oxidizing agents such as oxygen and ozone, which reduces generally the reaction of oxygen and ozone with the rubber reduces the quality or the life of products like tires. So the synthetic rubber is an artificial elastomer. As you know, all these rubbers comes under the category of elastomers. An elastomer is a polymer which is having elasticity property. So this synthetic rubber is an artificial elastomer. They are polymers generally synthesized from petroleum byproducts. So these polymers are generally, as we know, the polymers are hydrocarbons and the fossil fuels are hydrocarbons. This petroleum we are getting from the fossil fuels, like under heat and pressure, the fossil fuels are converted into the crude oil. Then the crude oil after refining converted into petrol, diesel, kerosene, etc. These fuels and these byproducts will generally yield the hydrocarbons. That hydrocarbons are the synthetic rubbers. After about 32 million metric tons of rubbers are produced annually in the United States and 2/3 of are synthetic. After total of 32 million tons, 2/3 of the rubbers produced are synthetic rubbers. The most prevalent synthetic rubber is styrene butadiene, which we are calling as SBR, derived from the polymerization reaction of styrene and 1,3-butadiene. This is what we are going to see today, which is nothing but the Buna-S rubber. Here, Bu means butyl, Na means this one, butadiene, and S means sulfur. And other synthetic rubbers which include polyisopropyl and prepared by polymerization reaction of isoprene units, polyisoprene, and neoprene, which is prepared by the polymerization of reaction of 2-chlorobutadiene, which is neoprene rubber, and nitrile rubber made from cyanobutadiene or 2-propyl-nitrile and butadiene. So these nitrile rubbers generally we are used in the preparation of hand gloves. The rubber, the elasticity property because of this elastomers is the nitrile rubber, which is made from cyanobutadiene or 2-propyl-nitrile units and butadiene. So we are going to compare the properties of natural as well as synthetic rubber. The hardness available will be 25 to 95, whereas synthetic it extends up to 10 to 95. Temperature is minus 40 to 80 it can withstand, whereas for synthetic minus 70 to 180 degrees centigrade it can withstand. The short time peak temperature is around 100, here 100 to 350. Coming to the tensile strength, 25 was observed in natural rubber, whereas in synthetic range it goes up to 8 to 30. The tensile elongation, the elasticity property is around 800. For the synthetic range, it varies between 150 to 800. The abrasion, the good abrasion was observed in natural rubber, whereas here moderate to excellent abrasion was observed in synthetic rubber. The flexibility should be excellent in natural and bad to excellent in synthetic rubber. So the resistance, because this synthetic range we are considering for all types of rubbers present in under the category of synthetic. That's why here moderate to excellent, bad to excellent. We cannot specify like here natural rubber is polyisopropyl. So we can specifically say which is good, a moderate or temperature. Whereas synthetic rubber, so many units can be prepared like neoprene, nitrile and polyisoprene, Buna-S, Thiokol, all are synthetic rubbers. So that their properties depends upon their chemical structure. So this was resistance to light, it was bad and bad to excellent. Resistance to oxidizing, it was moderate. Ozone, it was moderate, whereas they are moderate to excellent in synthetic rubbers. Wear and tear, very good in natural rubbers and bad to excellent in synthetic rubbers. Weathering effect was good, it was moderate to excellent. Resistance to petrol, it was unsuitable and unsuitable to excellent. Resistance to foodstuffs, suitable, unsuitable to excellent. Then resistance to oils and greases, it was unsuitable because it won't give the resistance for the oils and greases, but they are unsuitable to excellent. The resistance to water, it was good and unsuitable to excellent in synthetic rubbers. So the demand and supply factors that causes difference in natural and synthetic rubbers are generally for the production of natural rubber, it requires strength, flexibility, heat, resistance to tearing. So these are the side factors and 5 to 7 years lag because it is obtaining from the tree. So between planting and production. So it will take 5 to 7 years to get the latex from a tree. Once the tree grown only, after the plantation of the tree, only we will get the latex after 5 to 7 years. So there was a lag between the period of production, planting and production. So whether price and availability of seedlings, cost of labor, availability of and cost of land, profitability of rubber to other crops causes a side factor, supply side factor. Whereas in synthetic rubber, the production that requires abrasion resistance, heat and aging resistance, elasticity, resistance to grease and oil, the price of it depends upon because they are man-made and which are generally prepared from the byproducts of petroleum or crude oil. So it depends upon the inputs like the cost of the crude oil and the crude petroleum and the natural gas cost. So about the topic on today's presentation like styrene or Buna-S rubber. It is a copolymer of butadiene and styrene. Here generally 1:3 ratio of, here 1 ratio of styrene and 3 ratio of butadiene. The copolymer is formed in the 1:3 ratio. 1 of styrene, 1 part will be the styrene and 3 parts will be the butadiene. The percentage also we can see here. In the early days, the synthesis of this butadiene polymer, the sodium was used as a catalyst. The name buta is due to the buta means buta and this was butadiene. Here Buna-S. This is butadiene. This Na is due to the symbol. First, the sodium we are using as a catalyst. The symbol of sodium is Na. So, symbol Na was the, here Na is the sodium and S for styrene. So, the butadiene and styrene results in the presence of sodium catalyst results in the formation of butadiene styrene copolymer. So, here this is copolymer. So the homopolymer means the two monomer units will be same, whereas in Buna-S, the polymers we are using are butadiene and styrene. So the polymers are different, then it is a copolymer rubber. So it is also called as government controlled styrene rubber or SBR, styrene butadiene rubber. This Buna-S rubber is the first synthetic rubber developed and prepared for the copolymerization process of butadiene and styrene. So this is 1,3-butadiene. As we know, this is addition reaction where it having two bonds plus styrene gives rise to, in the presence of catalyst and heat, the polymerization reaction take place and result in the formation of this butadiene styrene copolymers, also called as Buna-S. And it is a random copolymer. The emulsion polymerization of mixture 1,3-butadiene and styrene in the presence of, it also happens in the presence of a peroxide catalyst, which is carried out with 5 degrees centigrade, whereas in the last, sodium acts as a catalyst. Here, last slide. Here, this SBR peroxide catalyst is acting as a peroxide is acting as a catalyst, and the reaction takes place at 5 degrees centigrade. This is why this is also called as a cold rubber. Whereas in the last slide, heat has to be there, and this is the different process of making the Buna-S rubber. This is called styrene butadiene rubber. And what are the properties of synthetic rubber? One of the synthetic rubber, Buna-S. It is strong and tough polymer. The rubber can be vulcanized with sulfur. As we know, the vulcanization is a process which is used to make the crosslinks or to increase the mechanical and the tensile strength of the polymer. So the vulcanization, why we are doing is to increase the strength of the polymer. We are making the crosslink. We are going to add sulfur. That sulfur acts as a cross-linking agent between the two linear molecules and result in the formation of the vulcanized rubber. So the rubber can be vulcanized. So the Buna-S is also ready to form crosslinks with the sulfur, and so this can be vulcanized by using the sulfur. It is a good electrical insulator and possess excellent abrasion resistance and resistance to chemicals and possess high load bearing capacity. This is why it was used in the aeroplane tires. So the loading capacity of these rubbers will be very high. So in the wheels, on the wheels, this rubber was used for heavy load vehicles. So what are the applications? They are used in manufacturing of tires and used in footwear for shoe soles. For shoe soles, this Buna-S rubber was used and used for making wires and cable insulators because it is highly electrically resistant. They are used in floor tiles, tank linings, etc. because they are ready to accept the load. Their load capacity and load bearing capacity is more in this Buna-S rubbers. Coming to the next category, one of the synthetic rubber like Thiokol rubber. Thiokol is prepared by the condensation polymerization process. It is done with the ethylene dichloride and sodium polysulfate and ethylene dichloride reaction. These are the monomers. In these elastomers, sulfur forms a part of the polymer chain. Here the sulfur, this is why Thiokol S rubber. This is called the Thiokol S rubber because of the presence of the sulfur in its chemical structure. We can call Thiokol S rubber. So the ethylene dichloride, sodium polysulfate and ethylene dichloride. So this is one monomer and this is one monomer if we see here. So the sodium polysulfate gives a sulfur, it gives the sulfur compounds. So this is suppose A, B, A. So A, B, A. The polymer unit will be like this. These are the monomers and the polymer unit will be like this. What are the properties of Thiokol S rubber? These rubbers possess great strength and impermeability to gases. So this is why making the advantages of using the sealings. So the sealing material, this Thiokol S rubbers was used. These rubbers cannot be vulcanized like this Buna-S rubbers as it already contains sulfur compounds because its structure is not similar to natural rubber and cannot form the hard rubbers. It possesses extremely good resistance to mineral oils, fuels, oxygen, solvents, ozone and sunlight. So they are extremely good resistance to all the chemicals and also the oxidizing agents like oxygen and ozone and also sunlight. They give the excellent resistance capacity. What are the applications of Thiokol S rubber? The fabrics coated with Thiokol rubber are used for barrage balloons. It is also used as solid propellant fuel for rockets and also used for making gaskets as it acts as a gas leaking proof. They are used in making the gaskets of our hoses for different applications. Used for printing rolls, it contains containers for transporting solvents because as it is chemically inert and it gives the good resistant capacity with the oxidizing agents as well as the oils, greases. So it is used and also some organic solvents. It is used in transporting the tankers, liners was prepared using this rubbers. Diaphragms and seals in contact with solvents are usually made up of this Thiokol S rubbers. This is what all about the Buna-S and Thiokol S rubbers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.